The next method of forecasting we're going to look at is a simple linear regression. It's a widely used tool for understanding the relationship between a dependent and an independent variable. In order to perform this analysis, what we need is some historical data. So in this example, you can see here what we've got is by month the number of radio ads that were aired by a company and the revenue in that month. What we then do is create a scatterplot chart in Excel and graph a line of best fit. The equation of that line becomes our formula for forecasting in the future. And as you can see, these dots are all plotted fairly close to the line. That means there's a strong correlation between the number of ads that are played on the radio and the revenue that this company generates. Let's jump into Excel now and build this together. We're continuing in the file called forecasting template-blank, and we want to understand now the relationship between the number of radio ads that the company runs each month and the amount of revenue that it generates each month. So to do that, we'll do a simple linear regression. Let's select all of this data, and then let's insert a chart. And we're going to insert the scatterplot chart, this one right here. So let's take that, stretch it to fit more of the screen. We can delete the grid lines since we don't need those. We just want to have a very clean chart here. Then clicking on these data points and right-clicking to format data series. We can format by clicking on the paint can, the marker. So we want to select the built-in marker. We can decrease the size a bit. We can make the fill color a brand color. So in our case, we'll make it CFI blue, no border. And now we've got a clean-looking scatterplot chart. We'll give it a title. We'll call it Ads versus Revenue. And then clicking on the actual data series itself, right-clicking, once again, we can add a trend line. We want a linear trend line, that's the default. We want to show the equation and the R-squared value on the chart. Close that, and let's drag this into place. So what we can see here is for any number of radio ads plotted across the horizontal axis here, we have a certain value of revenue that's generated. And the equation is equal to 78 times the number of ads that are placed. So that means each ad is generating, on average, $78 of revenue, plus some baseline amount of $7,930. So that's the formula. And then the R-squared of 0.93 means that 93% of the variance in revenue can be explained by the number of radio ads that are run. This is a very high R-squared. With the chart in place, let's go back to our table here, and let's sum up the total number of ads for the period, as well as the total value of revenue for the period, and then let's calculate the averages as well. So average for the period here, and then average again for the period. So we've got these numbers handy, and we can use them in the upcoming lessons.